Hello, my name is Olga García Menéndez and I work at IGME CSIC. I'm a partner of the Stars for Water project in the Duero River Basin. As you can see, Stars for Water stands for supporting stakeholders for adaptive, resilient, and sustainable water management. It's a project co-founded by the European Union through the Horizons Europe program. In this webinar, I will present a diagnostic methodology for assessing groundwater resource availability and supporting the local and ongoing management of groundwater use. By the end of this video, you should have gained an understanding of the methodology used to assess the status of groundwater, which comprises the Groundwater Resource Availability Index, reference piezometric levels, and application guidelines along with its implementation in the Spanish Duero River Basin. In developing this methodology, our main goal was to create a practical framework that could be adapted to different hydrological, climatic, and management contexts. We aimed for a simple calculation process using data from standards monitoring programs, with the results that are easy for stakeholders to interpret. Ultimately, the methodology is designed to support the local and continuous management of groundwater resources. The groundwater status assessment methodology is based on 4 key components. Piezometric level strengths are used as an indicator of groundwater dynamics over time. The Groundwater Availability Index reflects change in the availability of the resource. Application guidelines combine piezometric reference levels, piezometric trends, and the index to determine the current state of groundwater. Once the status is established, management standards defined by the Water Authority can be applied to regulate groundwater use and ensure sustainable resource management. The Groundwater Availability Index is defined as the slope of the piezometric level trend line, expressed as a percentage over a calculation cycle. A calculation cycle refers to the time period over which the index is assessed. In our case, we propose a duration of 6 years, in line with the hydrological planning cycles established by the Water Framework Directive. The index is calculated at each selected control point, starting with the generation of high water series and low water series. The high water series is constructed using the maximum annual piezometric level values recorded during the January-May period. The low water series take the minimum value recorded during the July-October period. From these two series, an annual average series is generated, which is used to calculate the index. The process consists of a sequence of calculations, slope estimation, conversion to radians, transformation to sexagesimal degrees, and finally to a percentage. This sequence is straightforward and can be easily automated. To streamline this process, we have developed an Excel macro to input data from the high and low water series, generating the annual average series and the corresponding index values. The groundwater status assessment methodology has been applied to the Spanish Duero River Basin. For this purpose, a general reference piezometric level for the entire basin was defined, based on the level recorded in 1990. Additionally, a set of application guidelines was established defining for groundwater status categories: good status under observation, poor status in recovery, and poor status in degradation. The category good status is defined as a current piezometric level that is either above the reference level or at most up to the 25% below it. This threshold is based on the maximum negative deviation observed in piezometric levels from the reference year. Good status under observation refers to the same piezometric condition as good status, but the index value is negative. Poor status in recovery is defined as a current piezometric level below 25% of the maximum difference recorded between the reference level and the current level, and the index is positive. Poor status in degradation refers to the same piezometric condition as poor status in recovery, but with a negative index value. The methodology has been applied to 42 monitoring points, specifically those with measurements available from 1990. Of these, 67% have been diagnosed as being in poor status. We conclude with a summary of the methodology's strengths and weaknesses. One key limitation common to all approaches based on monitoring networks is the uncertainty regarding whether the selected control points are truly representative of the hydrological context of the area. The methodology also requires operational monitoring networks with a regular and reliable measurements, and a set of definitions such as calculation cycles, reference levels, and application guidelines that must be applied with clarity and consensus. The possibility of applying the methodology depends on the reference level chosen, as shown in our case study with 42 applicable points. If the most hydrologically meaningful reference level results in too few applicable points, it becomes necessary to define alternative compromise reference level, always taking into account the hydrogeological characteristics of each area. We now turn to the strengths of the methodology. First, it relies on a single, easily available indicator, and the calculation procedure is both simple and easily automatable. It does not require daily or monthly data, and can be applied to time series with some irregularity in measurements. The methodology is sensitive to variation in piezometric levels through the use of slope, and its simplicity allows for annual groundwater status tracking in a straightforward way. It is also flexible in terms of spatial scale. It can be applied to individual points, zones, water bodies, or even entire river basins. Its methodological foundation and graphical outputs are easy to interpret, and the approach can be extended to other parameters such as electrical conductivity, nitrates, and more. You are able to leave a comment or ask questions via our website. You can also watch the following additional webinar to further enhance your knowledge.